Welcome everyone. So today we're going to discuss about Zeeman effect. So Zeeman effect, the phenomenon of splitting of spectral lines emitted by atoms placed in a magnetic field, is called the Zeeman effect after its discoverer P. Zeeman. There are two types of Zeeman effect, normal Zeeman effect and anomalous Zeeman effect. And today we're going to discuss about normal Zeeman effect. So now we're going to discuss about normal Zeeman effect. Normal Zeeman effect, the splitting of a spectral line into three components in a magnetic field when viewed in a direction perpendicular to that of magnetic field. It is known as normal Zeeman effect. When an atom is placed in magnetic field, its spectral line splits into different components. When it splits into three components, we called it as normal Zeeman effect. Now, the explanation of normal Zeeman effect is that let an atom having orbital angular momentum L only be placed in an external magnetic field B along z-axis and its orbital quantum number is L and energy E. Then the interaction energy delta E of the atom due to interaction between magnetic field and magnetic moment delta E is equals to minus mu L dot P, which is equals to minus mu L B cos theta. Here theta is the angle between mu L and B. So the angle between mu L and B is theta. Now, according to space quantization, mu L is equals to minus E by 2m into L vector, which is equals to minus E by 2m root over L into L plus 1 h cut. If theta be this angle, then cos theta equals to ml by root over L into L plus 1 h cut. So cos theta equals to ml by root over L into L plus 1 and delta E is equals to E h cut by 2m root over L into L plus 1 B into ml by root over L into L plus 1, which is equals to ml E h cut by 2m B, which is equals to ml mu B into B, where mu B is E h cut by 2m. Now, the energy of the electronic state ENL is equals to En plus ml mu B B. Since ml can have 2l plus 1 different values from minus L to plus L, the energy can have 2l plus 1 each slightly different values, each determined by quantum number ml. Now, any transition between two subshell governed by selection rule delta L equals to plus minus 1 will be controlled by the selection rule delta ml equals to 1, 0 or minus 1. Considering the transition between the initial and final energy levels EI and EF, where EI is equals to Ni Li plus ml I mu B B and EF, which is equals to ENF LF plus ml of F mu B into B. Now we are going to consider the transition between two energy levels EI and EF. Now, considering the transition between initial and final energy level EI and EF, we get delta E equals to EI minus EF. So H nu is equals to EI in Li EI minus EF plus delta ml mu B into B. Now nu equals to E in I. Now, considering the transition between initial and final energy levels, delta E equals to EI minus EF. So H nu is equals to ENI Li minus ENF LF plus delta ml mu B B. So nu is equals to ENI Li minus ENF LF by nu plus delta ml into mu B B by H. So we can write this term as nu 0 and the mu B by H cut term in this way. So now we will get the expression of nu in this way, that nu equals to nu 0 plus EB by 4 pi m delta ml, which is equals to nu 0 plus ml delta nu. We can write this term as delta nu. So nu equals to nu 0 plus ml delta nu. So depending on the delta ml values, nu can take different values. As we know that delta ml can take three values, that is 0, plus 1 and minus 1, and depending on these values we get different values of nu. So nu equals to nu 0 when delta ml is 0, and nu equals to nu 0 plus delta nu when delta ml is 1, and nu equals to nu 0 minus delta nu when delta ml is minus 1. Here nu 0 is the initial frequency of initial line is nu 0. So now from this diagram we can see that L equals to 2 state will split on different states depending on the value of ml, where ml can take values plus 2, minus, plus 1, 0, minus 1 and minus 2. Similarly, L equals to 2 will split for different states depending on the value of ml, where here ml can take values plus 1, 0 and minus 1. Now the transition between these states will follow the selection rule, which is delta ml equals to 0 and plus minus 1. Now if we consider the transition between ml equals to 0 and ml equals to 0, here delta ml is 0, so it will give us the new 0 component. And also for the transition between ml equals to -2 to ml equals to -1, and the transition from ml equals to -1 to ml equals to 0 and ml equals to 0 to ml equals to 1, here the change in delta ml is -1, so it will give us this component, that is new 0 minus delta new. And for this lines here the change in delta ml is +1, because if we consider the transition between delta ml equals to 0 to delta ml equals to -1, and if we consider the transition between ml equals to 0 to ml equals to -1 and ml equals to 1 to ml equals to 0, and the transition between ml equals to 2 to ml equals to 1, here the change in delta ml is +1, so it will give us this component, that new plus delta new. So depending on the delta ml values we get these three types of lines. And so this is the splitting of energy levels in magnetic field, and we'll get this type of possible transitions. This was our discussion on Zeeman effect, and we have discussed the explanation of Zeeman effect and the splitting of spectral line. And on our next class we'll discuss about different topics. Thank you everyone.